Alrighty, guys. So today we're going to work with limits again. We worked with limits yesterday. It's the same definition. I just have it up here again so we can see it again. So the limit is the y value that the function approaches. Oop, that's not a pen. As x approaches a given value. So today we're going to be working with algebraic equations as opposed to pictures. Yesterday we did pictures. Today it's algebraic. The y value the function approaches as x approaches a given value. This is just limits. Limits actually isn't in the book, but often shows up on the final, so we're kind of squeezing limits in. Two erasers in my pocket. Yeah. Yeah. Finals in December.
And that final counts for what?
The final?
Final for like the entire class, or the ones that were ended in year 2?
No, there's one at the end of the year too.
Great.
Yep. All right. So what we're going to do is we're going to find the limit. So what y value our function is approaching as x approaches the number that we got like way down here, the teeny tiny one. I'm going to zoom this in so you can actually see stuff, because I know these are sometimes very, very tiny. So here's our first one. We've got the limit as x approaches -4 of the function 2x plus 8 over x minus 9. The easiest way to find the limit, substitute. Substitute it in. See if you can see the value there. So what we're going to do is we're going to substitute in -4. So 2 times -4 plus 8 over -4 minus 9. Because if the x value actually exists in our function, it's just going to be where the line is. So what do we get? 2 times -4 plus 8, 0, over -4 minus 9, -13. What is 0 over -13? 0. So the limit is 0. If you get a value, that's your limit. So algebraically, substitute it in. So let's look at the second one. The limit as x approaches 2 of x squared plus 3 over x minus 2. So same thing. We are going to substitute in this x value. So we're going to take our 2 squared plus 3 over 2 minus 2. What do we get when we simplify this? 7 over 0. What does that mean? It doesn't exist. And if the number does not exist, the limit does not exist. Okay? Feeling okay on that? We're going to try this a couple more times before we kick it up a notch. Because, of course, this is not as hard as it gets. Of course. Pshaw. You ready for me to change it? Okay. Just making sure before I change this. So 2 more like this. I'll zoom it in on 3 so we can see it. So the limit as x approaches -1 of x squared plus x minus 2 over x squared plus 6x. And we're going to substitute this in. Just like we did on the last one, we're going to substitute in our -1. So we want to know what -1 squared plus -1 minus 2 over -1 squared plus 6 times -1. Substitute it in every place you see an x. What do we get when we simplify that? Two fifths. We actually get like -2 over -5, but it simplifies down to be just 2 fifths. So our limit is 2 fifths. One more like this until it kicks up a notch. Same vibe. The limit as x approaches 4 of this guy. X squared plus 4x minus 12 over x squared minus 2x plus 8. Substitute in that 4. What do we get? When you simplify this, what do you get? Not 36. So 20 over 16. Also known as what? What does it simplify down to? 5/4. Okay. How we feeling on those? For the most part, we just substitute in and check. But we're going to have one kind of weird situation we got to watch out for. We'll see it. Which is this one. Is going to be our first one where we see it. Do you have a color preference? So when we substitute in 2 here, what do we get? We get 0 over 0. What 0 over 0 means is that this is hitting right at a removable discontinuity, or there's a hole in the way. Somebody stabbed our equation, and we're trying to figure out what's happening as it approaches that hole. So we got to get the hole out of the way. So we're going to factor. Factor this. Yeah. So what we're going to need to do, if you get 0 over 0, that means there's a hole. There's a removable discontinuity. So we need to come back to our original equation and factor it. We need to factor this. This is a difference of cubes. It's been probably a month since we factored our difference of cubes. It's the soap thing. Yeah. So when we're factoring our difference of cubes, we find our terms. Ooh, not that pen. Gross. We're going to have our x and our 2, because 2 cubed makes 8. Where it has the same sign, the opposite sign, and then the last one's always positive. But our terms over here are the x squared, our 2 squared, which is 4, and then the 2 times x, 2x. It's been a hot minute since we did that kind of factoring. And in fact, I'm just going to erase this and change color. This is our denominator from the left-hand side. So these two things mean the same thing. What's the benefit in factoring this? We see what's going to happen here? It cancels. What cancels? The x minus 2 cancels out. That's where that removable discontinuity is. That's where that hole is. So to find our limit, what we're going to do is we're going to take that leftover bit, x squared plus 2x plus 4, and that's what we're going to substitute into. So we're going to take our x is 2 and substitute it in over here. So what do we get as our limit? 12. So as x approaches 2, our function approaches 12. But there's a hole right at 2. But our limit still is 12. So if you get 0 over 0, that means there is a removable discontinuity or a hole. Okay. Questions on that one? Or on any of the ones beforehand, because I didn't actually stop for questions. Yep, 12 is our answer. Our limit is 12. Okay. We're going to try this a few more times. Next one looks kind of gross. And we approach it a kind of weird way, but it's the same vibe. So what we have is we want to know the limit as x approaches 9 of the square root of x minus 3 over x minus 9. So when in doubt, let's see if we can substitute it in. Square root of 9 minus 3 over 9 minus 9. And we get 0 over 0. If it's 0 over 0, that means there's a hole. So we got to do something to factor this thing and see if we can cancel something out. I have x, or square root of x minus 3 on the top. I'd really like if we could cancel that out, because that's super gross. So what I'm actually going to do is I'm going to treat this piece like a difference of squares. We're just going to do it as a difference of squares, where square root of x squared is just x. So I can write this as a difference of squares. That's square root of x minus 3, square root of x plus 3. See that? Square root of x squared minus 3 squared. You can do that. It's not often handy. In fact, this is one of the only times I've ever seen this be something that is actually handy. You can do that. It just doesn't often help. In this case, it helps because why? Because I can cancel this one out. I can get this numerator to cancel out. Whoop. Which will remove our whole. What's left as our numerator? 1 over square root of x plus 3. And so we're going to take our what's left over, not that, and substitute in our 9. One over square root of 9 plus 3. What is our limit? 1/6. So they get a little weird and they get a little wild. But we got to simplify and then substitute in. Okay, you ready for your next one?
No, wait.
Okay, totally fine. We've got time. I only have 3 more for us to do. Only. To be fair, we've done 2, 4, 5, 6. Because I just wasn't counting the one on the screen I'm on right now. We've done 6. I only have 3 more. Okay? So we should have time like we did yesterday. I'm just going to say breathe. So we want the limit as x approaches 0 for this one. 1 over x plus 5 minus 1/5 all over x. Did you just say you look majestic?
Yeah.
Okay. All right, so let's test it and see if we have to do any kind of simplifying anything first. Let's see if we substitute in that 0, what we get. What do we get in our numerator?
0.
What do we get in our denominator?
0.
That means there's a hole, so we're going to have to do something. So let's simplify the top. Let's look at this numerator up here. What do we need to do to simplify this numerator? So we need to multiply this one by what? X plus 5. What do we need to multiply this one by? 5. So this is going to give us a numerator of 5 minus x plus 5 over 5 times x plus 5. Right? Because we can see the whole thing. There we go. We see that part? Simplify the top more. What happens with that numerator of the numerator? 5 minus x plus 5. So distribute the minus sign. So 5 minus x minus 5 simplifies down to be what? Negative x over, our denominator is going to stay the same, 5 times x plus 5. What is an easier way for us to do operations with this all over x? Multiply by the reciprocal. So we're going to times 1 over x. And what happens? How can I simplify this next? The x's do what? Cancel out. So our simplified, once we got rid of that whole situation, is negative 1 over 5 times x plus 5. So now we're looking for our limit as x approaches 0. Negative 1 over, 5 times 0 plus 5. So negative 1 over 25. Negative 1/25. That's our answer. That's our limit. Okay, I'm going to do the hardest one and then we'll end with a less gross one. Yes, dear? We took this piece, the all over x.
Wouldn't it be x over 1?
It is currently x over 1. It's divide by x. So I could write divide by x. So times 1 over x. Okay. I don't know why I wrote that with a highlighter, but, it's choice. I'm just sticking with it. Okay. So the next one's the hardest one. Okay? That's what I'm saying. So our very last one will be less hard than this. All right. So we've got the limit as x approaches 0 of this. square root of x plus 16 minus 4 all over x. So let's try it substituting in. See if we get lucky. 16 plus 0 minus 4 over 0. Well, we've already got a 0 in our denominator. What happens in our numerator? So it's 0, which means we have some sort of whole situation going on here. And we have to do something to try and simplify it. Can we factor that thing? No. Can't even really force to complete the square because it's already being square rooted. Conjugate. Remember that conjugate thing? We're going to multiply by the conjugate. So what we're going to do is we're going to come in here on this guy, on our numerator. We're going to take our square root of 16 plus x and the 4 with an addition sign. Square root of 16 plus x plus 4. It's this piece and this piece with the opposite sign. You see that? Vaguely familiar? When we multiply those together, our 16 plus x, square root of 16 plus x, when they multiply together, we have our 16 plus x outside of the root. We love that. Minus 4 times this, positive 4 times this, those guys cancel out. And we get a minus 16 with the 4's timesing together. That's a 16. And the denominator is going to look gross, and we're going to leave it gross. We have x times that guy. 16 plus x plus 4. Does everyone see where those pieces come from and go? Like I said, this is the hardest one. What happens in the numerator? The 16s cancel. And we have x over x times that guy. So this came down. What can I do here to simplify? Cancel the x's. So we have 1 over this guy. And now we're ready to look for our limit again. I'll zoom out. Now we're ready to look for our limit again. We're going to take this simplified, changed, morphed guy and substitute in our 0. So we have 1 over square root of 16 plus 0 plus 4. And what do we get as our limit? 1/8. So it's a whole lot of work to get 1/8. Okay? I'll leave this up for just a second, just because I know there's a lot of steps here. Ready for one last one? Less gross than this?
Yes. And I think I'll be able to fit it on one page.
Probably. It took me just a single line to get it across on my notebook. Ready? Okay, cool. Last one. We want the limit as x approaches 2 of 3x squared minus 7x plus 2 all over x minus 2. So first things first, let's see if we got lucky and see if we can substitute this in and not have to factor things. But it's possible, so it's always good to check. 3 times 2 squared minus 7 times 2 plus 2 all over 2 minus 2. Well, I already see a problem in my denominator, so I'm not optimistic. So we've got a 0 in our denominator. What's our numerator? It's 0. So there's a hole somewhere, so we got to find it and cancel it out so we can do that. So we need to come through and factor it. Is it a cube? Nope, so we're not going to use soap. X and box, if you want to. If you're an X and boxer, you could factor by grouping. You could split the middle. You can do whatever method you choose. We're going to need to factor it. Lots of options when it comes to factoring a trinomial. Most of them involve us finding these two values where we have our a times c at the top, our b at the bottom. A times c gives us, and our b is, what's a pair of numbers that multiplies to make 6 and adds to make -7? -1, -6. Do not just hop into factored form because we have an a value of 3, which means we do need to either factor by grouping or throw it through the box or do something. Because we have that a value. With our 3x squared and our 2 from our equation, our -1x, our -6x. I don't care if you use box. I don't care if you do factor by grouping. You could absolutely do this the way that we do when we divide things into pairs of data. You get the same pieces. I'm just tossing the box up there because for a lot of us, it's very familiar. So what are our factors? What's our factored form here? (3x minus 1). It's definitely not x minus 6. X minus 2. Slow down. Because for some of us, I heard a couple of people just start popping that -6 out of there. I can't take 6 out of 2. Be careful. So now that we have this in factored form, do we see what's happening here? What cancels? The x minus 2's cancel. And we're left with just 3x minus 1. So what is the limit as x approaches 2 on 3x minus 1? Boop. Okay. So they're super fancy looking. They're annoying to write because they're really long to write. It starts as substitution and then it's simplifying it. It's all things we've done, just in a slightly different way. Okay? So you guys have 7 minutes. There are 6 questions on the worksheet. If you're fast, you can finish it. It's the same worksheet from yesterday. Tomorrow, there's not like a video or anything posted. Like tomorrow, catch up on stuff. Because tomorrow's PSAT. I still don't know if I'm going to see any of you. because they still haven't given us
I
a
know,
schedule.
I'm like concerned that it's
I love it so much, right? We love this so much.
They wait till tomorrow morning to tell us.
You should have an email with what room you go to onto your school account.